Okay, good evening, all of you.
Good evening, sir.
Good evening, sir.
Good evening, sir.
Saran, I think you have not collected the handbook yet. So you send me a message. Okay. Either you can collect it in the center or you can collect it in my home.
Okay, sir. Okay, sir.
Yeah. Whenever you or your where are you staying? Where is your home?
Sir, in Ramanujanagar, sir, Pilamid.
Okay, so it's a little bit farther. So my home is in Ramnagar. Our center is here in Arspuram. So if you are coming this side, you can check with me. Wherever I am there, you can come and collect it.
Okay, sir. Okay, sir.
Or you can, or your parents can collect it.
Okay, sir.
Anybody else who have not collected the handbooks? I hope all of you have collected it. Okay, let's see. Shasti. Okay, in the previous chapter, I think we talked about centripetal force, right? The force acting towards the center is what is causing the circular motion. And I told you that there are a lot of circular motion examples, such as a ball, spinning around with a string, or a moon going around the earth, or a plane taking a turn, or a conical pendulum, like a cone, right? You can take a pendulum and make it go around like a circle, or a cyclist taking a turn. So all these things are an example of circular motion. Okay. So this topic I given it in chapter 4, but some of the derivations are coming in this chapter 5. So let's quickly go through that. Again, I sent you a message. Okay, so I'm trying out a new online testing software, like a platform for the JEE and NEET students. So I'm planning to use the same platform for you folks also for the CBSE preparation. So it's like when I'm preparing the test paper, it will be like easy, moderate, and difficult. So I will try to give 20% easy, 60% moderate, and then 20% difficult. Or maybe this will change. So maybe this will be like 40% and this will be 20%, something like this. Okay. So difficult will be the percentage will be less. So as I always say, the theory is your first step. Doing the numericals is your second step. Okay. Only if you do these two steps properly, you will be able to score well in your school exams. And remember, as I've been telling you, don't think that okay, sir, 11th I don't care too much. I will study in 12th means anything can happen. Okay, just like what happened for the previous batch students. So they took the marks from 11th. So that is a good motivation for you to study this year also properly, because many of you will be thinking, sir, 10th I studied very hard, so 12th I will go back and study, so 11th I will take a little bit rest. Well, you don't have time for taking rest. Okay, so study properly. Then the third step is your JEE main. And NEET. And even more, next step is your JEE advanced. Okay. So generally, as I always say, doing these two things, it is must for you. Okay, you don't have a choice. You have to do this. If you are taking a little bit of extra effort, you can do well in this also. When I say JEE Main, it includes all the VAT, Amrita, BitSat, right? Manipal Institute of Technology, so MIT. So everything, all the other entrance exams are included. If you prepare for this, all the other things are included. Okay. So most of you, 80% of the students, who are studying here, if you are doing this part very well, you folks will be able to come to this level very easily. JEE Advanced is completely different. It's much more. I mean, it's not difficult, but you have to spend much more time. Usually, I've seen students who are able to spend one more year after 11th and 12th to study specifically for JEE IIT. Then they are able to do this. Okay. Otherwise, sir, I just don't want to spend one more year on that. Means you can do your this part and this part, and then you can easily find good colleges. Okay. Of course, JEE Main you can get into NITs. So I'll be taking more questions from easy and moderate so that you folks are comfortable here, and then little bit of questions from difficult. So before Sunday, try to send your details to Sunil sir. So you'll be entering it in the software, and then using your email ID and password which I give you, you will be able to take the test. Guru Academy. Yeah. So when you enter this, I think you'll be able to get the screen. Then you can enter your email ID. I'm still working with these software guys. So it should look something like this. So I'll be setting up the time. So within that time only you'll be able to take the test. If you try to enter after the time, you will not be able to take the test. I'm already using this for the JEE and NEET students, course students. So this is how the interface will look like for most of your entrance exams. Okay, you'll be having the question numbers here, green. So when you attempt something, it will change in the different color. So after the test, you will be able to see the solutions. You can study them. And one more thing, very often, suppose if your internet is having some trouble, what will happen is even if the internet is disconnected, this will still be there. So you should not close the window. So listen carefully, very important. You should not close the window. Okay. If you close the window, the test will be over and you will not be able to take the test again. Okay. So even if the internet is disconnected, you will still be able to continue the test. And only for submission, you need internet. So that means what I mean by that is you can complete the entire test. And when you're doing the submission, the internet should be connected. So if you do that, it will work. So until then, you should not close the window or you should not switch off the computer. If you don't do these two things, this will not get affected at all. Okay. So I see many of you are showing a lot of interest in numericals and then the difficult problem solving. So my suggestion is, if you do it seriously, I'm sure you will be preparing both for your CBSE exams, school exams, and also for your entrance exams. Okay. So as I always say, it's not two different things. If you do this, I'm sure you can easily jump to the next level. You should take some little bit of extra effort. Okay. Any questions in this? Okay, so this is your top view. When the car is taking a turn, it's going in a circular motion. The force, I told you, whenever there is a circular motion, there must be a force acting towards the center. And that is given by the frictional force between the tires on the road. So we talked about this many times. So if you see from the side view, I mean back view, the car is going like this, then the force is acting towards the center. And the weight is acting downwards. And the normal reaction is upwards. This is your F friction acting towards the center. And you are taking a turn this way towards your left. F friction, just now in this chapter we have studied that F friction is mu into N. Who is providing the centripetal force? F friction. So that means mv squared by r is equal to mu N. What is N? N is equal to mg. That means you know that this and this are equal. The car is not coming out of the road. The car is not breaking into the road, which means this and this has to be equal. Mm cancels. So if I take the r on this side, I'll be taking v squared is equal to mu rg. What this means is, for a given friction, coefficient of friction, and given radius r, right? This is the maximum velocity I can take. If I go beyond this value, right? So listen carefully. This is your F friction is equal to mv squared by r. So F friction is the force who is providing it, right? Force provided. This is force. Anybody? What is this called? Force. Centripetal force. Talked about this so many times in the previous chapter. Nobody is answering.
Demanded or required.
Demanded,
force or required.
Demanded, yeah. Demanded or required. So what does that mean? It means that this friction, right? This is coming on this side. So mu n, which is mu mg, is equal to mv squared by r. What does that mean? This value, if it is more than this, then it is safe. But then if this value is more than this value, then it is not safe. So that means the v has to be velocity has to be less than this value. Okay, if you do the math, this and this cancels. So in other words, the inequality sign will look something like this. This has to be more. This has to be less. Anybody not following this? So the demand should be less. What you provide is more. So that means the inequality sign should go like this. But when you say equal, it is a maximum situation. So that's why I've used v squared max is your mu rg. or say turning, this has to be less than this. That's why we reduce the speed. Any questions? Anybody not following anything? Very, very simple, nothing very difficult. It's very hard for you to imagine that. Why do I say that the frictional force is acting towards the center in this direction? But as I told you many times, if there is an oil spill, you will not be able to take a turn. It will go straight. So that means we have to agree that the frictional force between the road and the tires is what is making or helping us to make a turn. Otherwise, I'll not be able to make a turn. Okay. The next concept is, you must have heard about banking, right? What is banking? Anybody?
The bank angle is basically when the angle, if you have, when I've heard the bank angle in aviation, basically when the aircraft turns to left or to right, where it loses its balance and then it crashes eventually.
Okay. Yeah. So you're talking from a airplane point of view. That is also correct. No, we call that as banking.
Sir,
So,
by turning the vehicle or the moving body just not turns to the sideways. The center of gravity just changes.
okay. So listen carefully. So if you take the cross section of the road, right? The road will be, if the road is made like this, the car will be standing like this. So that's your tires. So that's your tires. So I'm seeing it from the back side. So if you see the road, instead of being the road flat like this is a flat road, which means the car is like this. Whereas here, this is a banked road. So take it down. Have you seen this kind of roads anywhere? Where have you seen it?
So while you're on a hill station road,
Hill station road, very good. Anything else?
Or hairpin bend, sir.
Where?
Hairpin bend, maybe.
Hairpin bend, yeah, that's same as hill station. Okay. Anything else?
Or even a flyover or
Flyover, okay.
so
Yeah.
when we go for track testing on a racetrack, so if you're testing cars, basically there's a huge turn like the bank angle one. So over there, the cars, when they take it for testing over there, it will be shown.
Okay, yeah.
So currently, if you search for NATRAX for India, it's there. It will show a clear example, sir.
Yeah, you're right. So what you said is perfectly correct. So you will see this kind of banked roads. You see this. So when you are doing some testing of the cars and buses or any automobile, they will do this kind of testing. And also you can see it in the race tracks. Okay. It's also, this is a flat road here and you can see the banking here. So why do you think they have to do this banking in the race tracks? Any idea?
So this is how competition will increase. Basically, you can easily overtake here. Plus, it gives you enough speed, and then there'll be stability also.
This is a beautiful picture. Look at this. The actual road is like this. This lady is standing straight like this, and you can see the road is, the race tracks are like this. So it's almost like vertical. Okay, maybe you don't recognize this or realize this in a when you watch it in the TV, but you can see it like this. What's that?
But in real life, it will be too much. The
Yeah.
angle.
Yeah. Yeah, you see this one, it says 31 degrees. So that's a huge angle.
Oh, sir, all these NASCAR tracks are basically just in an oval shape where the turns have these bank angles.
Yeah. Okay. So what you said is somewhat correct. Let's improve upon your answer, this understanding. So listen carefully. You know that the mg will always act vertically downwards. You know that the normal reaction will always be normal to the surface. So that's your n, because normal to the surface. We're talking about this surface. Okay. This is a very important understanding. Weight will always be vertical this way. Normal reaction will be always straight this way. Then what I can do is I can split this into two components. If this is theta, you know that this is also theta. If this is theta, this is also theta. If this is n, this will be n cos theta. If this is n cos theta, this will be n sin theta. Imagine that there is no friction here, right? Let's assume that, of course, it's not true. There will always be some friction. But imagine that there is absolutely no friction, right? So in this racetrack, right? And imagine that the racetrack is going to look something like this. So this is the force which is acting towards the center, which means n sin theta is what is going to give you the centripetal force. Okay. So take it down. Case 1, no friction. Yeah. So n sin theta is acting towards the center. So that should be equal to mv squared by r. So this is your provider. This is your required. So listen carefully. Now, if you see this and this, right? In the previous case, in the flat road, what did we say? N is equal to mg. But that is true only in the flat road. Okay, so this is flat road. That is not true always. So if you see this diagram, this and this are equal because the car is not flying out of the road. Car is not breaking into the road, which means this force and this force has to be equal. So if I take this as equation 1 and equation 2, I can say n and n will cancel. So 1 by 2 sin theta by cos theta will become tan theta. M and M will cancel. So I will be getting v squared by rg. Okay. For a given track, radius is fixed. You are living in the earth, which means the g is also fixed. So what does that mean? As the theta increases, the velocity, the maximum velocity will also increase. I told you equal to means maximum velocity. Okay. So it means as the theta keeps on increasing, I can go at a higher speed. So it means now you should know why the racetracks have such a very vertical bank like this, 31 degrees or something. Okay, any questions? So take it down. I'm not given this in the handbook, so take down the drawing properly. Any questions? Can anyone tell me where did this n sine theta come from? How come when the road is like this, the n sine theta did not appear, but now there is n sine theta? Why? Anybody?
An angle is formed,
What angle?
theta.
With the flat road, right? So
Yes,
because of this angle, right, that the vehicle is experiencing a normal reaction, not like this. Very important understanding. None of your textbook is going to give you this understanding, so take it down properly.
Sir, sine 0 is nothing but 0. So n sine theta is nothing but 0.
Yeah. So mg weight is acting downwards, normal reaction is perfectly vertical. But because of this angle here, what happened was you tilted the normal reaction. So the normal reaction was tilted this way. Since I'm tilting the normal reaction, some part of the force is acting towards the center. Okay, and that's why we are trying to use the banking. As Kirtan was saying, even in a plane, right? When the plane is flying flat, you're seeing from the back, plane will look something like this. But suppose if the, when you come towards the landing track, you will see that sometimes the pilot will have to make a turn. So at that time, you will see that you are getting tilted towards the side where you are turning. And that is what is called banking. So that means it's the same concept. So initially you have some weight here, then you have some lift force here. Instead of normal reaction, we call it as lift force. Why I cannot call this as normal reaction? Anybody? Is the airplane touching the ground?
So if it doesn't touch the ground, but it's close to the ground.
So since it is not touching the ground, I would not call it as normal reaction, because normal reaction is coming from the ground. Instead, we call this as lift force, because there is a lift force from the engine. The lift force is holding it up. But the moment you make the banking, what will happen is you are making use of this lift force to make the turn. That means I would call this as L sine theta and L cos theta. So take it down properly. So you should understand that what you do in a car is same as what you do in the aircraft. So it means I'll be taking this L sine theta as mv squared by r. L sine theta is equal to mv squared by r. Any questions? Take it down quickly. So intentionally to make it easier, right? I did not consider the friction here, but then there will be some friction. So I will have to consider friction also in this diagram. So let me copy paste this diagram. You have to draw it properly in your notebook. So let's consider the friction. So friction, I'm going to say it's going to act this way. The friction. But then if I draw the diagram here, right, I can split this into two components. So take it down properly. You have friction. So this is your theta. So if this is theta, this is also theta, which means this will be F friction cos theta. If this is F cos theta, this will be F sin theta. So now if I put this at the center, right, F friction cos theta is also helping to make the turn because this is also providing towards the center. So listen carefully. The way I would draw this diagram is N cos theta is acting upwards, mg is acting downwards, F friction sin theta is also acting downwards. Normal reaction, N is acting, N sin theta is acting this way, plus F friction cos theta is also acting this way. If you understand this, you will understand this. Anybody not following this, please ask me. If I draw all the forces acting on a body, right, what do you call that diagram?
Free body.
Free body diagram, FBD. Okay. So basically we are freeing the body from the rest of the system, and I'm showing all the forces acting on the body. So that's why it's called free body diagram. Now tell me, what is the force acting towards the center? Is it N cos theta or this total? Total, which means F friction is also helping, N sin theta is also helping. So this is the reality. To make it easier, I just gave the first situation without the friction. So this is also easy. Only thing you will get an extra term. So that's why it becomes a little bit confusing. So this and this will be equal. You know that F friction is nothing but mu into N, right? F friction is mu into N. I can say mg plus mu N. Remember, you should not write N is equal to mg. Okay. Very often we will make the mistake of writing N is equal to mg. This is not always true. So make a note properly. Only in the flat road this is true. Okay. When it is not a flat road, this is not true. So this and this will be equal. Why? Because you have to, maybe when you're drawing the arrows, it should be the same length. Okay. Why? Because again, the same concept. The car is not flying out of the road. It is not breaking into the road, which means this force and this force has to be equal. Mu n cos theta plus n sin theta is equal to mv squared by r. So that is your second equation. Why? Because this is acting towards the center, and that is what is causing the. Can anyone tell me what is the basis of this formula? What is the most important formula in mechanics?
F is equal to
F is
ma.
equal to m.
No. No. Sigma f is
Sigma
equal
F is equal to
to ma. So I told you have to do the vector addition of the forces. Okay. If you simply say f is equal to ma, it's not correct. So you have to say sigma f is equal to ma. So this is all the forces added. And I told you this is the cause and this is the effect. But here, instead of linear acceleration, you have rotational acceleration. And that's why there is a circular motion. In place of m, you have m. In place of a, you have v squared by r. So that means it is centripetal acceleration. So since it is acting towards the center, okay, it becomes mv squared by r. If it was linear, I would have kept it as ma. Since it is rotational, I'm writing it as mv squared by r. That's all. So take it down properly. These things may not be there in the handbook. Basically, I am interested. Usually, your theta will be given, mass of the car will be given, gravity is known, friction will be given, n will not be known, theta will be, banking angle will be given. Okay, so take it down properly. Theta is the banking angle. So two equations, two unknowns. What are the unknowns? N and V max. When I said whenever it is equal to, it is the maximum. So in your mathematics, you have studied in your 10th standard maths. Whenever you have two equations and two unknowns, you can solve for it. Okay, so simply solve for V max. You can do elimination method, right? So maybe I can find the n from this and then substitute it over here. So let's do that. Again, after this, after this it is physics. After that, it is mathematics. Okay. So just for derivation, I'm showing you all the method. But for your numericals, you can directly substitute the numbers and do it. This goes on other side, do the math and we'll get this. I want to replace n here. So n is equal to mg by cos theta minus mu sin theta. So I'm going to substitute n in this second equation. And that's what you in mathematics you call it as elimination method. So basically I'm trying to eliminate the n. I'm not interested in finding n, I'm interested in finding the V max. Radius of the circular motion is also given. Okay, it's a data given. So I'll be expected to find the maximum velocity with which the race cars can go. or safely. So I can take n commonly out. Always remember this is, since it is equal to, it is maximum. In reality, I should be writing this as the provided should be more than the required. Okay, that's how I should write. But whenever you write equal to, you can imagine that this is the maximum velocity with which you can go. If you go beyond this velocity, then it is dangerous. It can cause an accident. So now I can replace the n over here. So take it down. All these steps are not given in your textbook. It's not given in your handbook, because mathematical simplifications, you are expected to do it. I can
Sir,
take
can
the,
you show a complete steps, sir?
yeah, let me complete this step. R comes on this side, so it will be GR. You can stop it here, nothing wrong in this, right? If you stop here, but remember there's a square here. But generally in the textbook, what they have done is they are divided by cos everywhere. So if I divide by cos theta here, I can divide by cos theta here also, which means it will become GR mu. Cos theta goes away, sin by cos will become tan. Divided by, if I divide by cos, cos by cos will become 1 minus mu tan theta. Sin by cos here tan theta. So this is given your textbook. So you can stop here, but generally we like to have it in tan theta. It's simpler form. So is this visible? Can I keep it in this size?
Yes, sir, we can see no issues.
Very simple simplification. Mu generally, since you have static and kinetic, this one is actually, with respect to the turning, we will still call it as mu s only, static. Can anyone tell me why should I write it as mu s? The car is moving, so don't you think I should use mu kinetic? Why should I use mu s static? I think the explanation could be something like this. So when you are seeing the car from here, if you see the forward direction, then I should consider mu kinetic. But then we are talking about the friction acting this way. So the friction, so is the car sliding down the slope, or is it, going at the same location, within this marks? What do you think?
So within the marks, I believe.
So that means the car is not sliding downwards. Do you agree?
No, sir.
So since it is not sliding down, it is with respect to the banking road, right? It is not sliding downwards, which means it is static. And that's why we use mu as here. Okay. That might be slightly confusing. So
So if the weight balance inside the vehicle is proportional on each side, then you can say if we have seen a lot on hill stations, like the weights put are uneven. So there they'll be in trouble with the angle.
okay, you mean many people sitting on this side, more weight on this side than this.
Yeah, more weight on the side and than the other side.
Yeah, that's a good point. So again, that is not coming under this topic, but that is coming under stability concept. So you take you can try this experiment in your home. Very, very interesting experiment. Okay. So you take a water bottle, transparent water bottle, and you take the empty water bottle and then you tilt it. So the center of gravity, if it is, as long as it is falling inside this base, right, what will happen? It will come back to its original position. So if I leave it here, it will come back. But what if I tilt it too much like this? The center of gravity will be here. Yeah. The center of gravity will be here. So look at this. This point is here. So this is giving you a normal reaction this way. This gravity is turning this way, which means it will turn this way and it will lose its stability. So this is what is coming under stability concepts. So take it down. It's not required for this chapter, but somewhere your understanding will be improved. Whereas here what happened was when the center of gravity is acting inside this corner, right, inside the base, then you see this force is acting this way, this force normal reaction is acting this way. So here it is causing a counterclockwise. So this is a couple or torques which are causing this counterclockwise. Here it is causing a clockwise. So this is a concept of stability. So as long as you make the center of gravity to fall, this force to fall inside the base, then you are safe. You can come back to its original position. So try this experiment. And one more thing you can try with this is, again, we are deviating from the topic, but it'll be useful for your understanding. So to take an empty water bottle, you should have 3 water bottles of the same size. If it is transparent, it is good for you. So this one is empty. So this experiment, we have it in the lab. Okay, very simple, just have the 3 bottles. This one is filled completely up to this. This one is half filled. Out of this, which one is more stable?
The filled one.
Third one?
The
Why?
fully filled one.
Why? Any other answers? Let's think about it. Center of gravity, would you like to keep it at a very high point, or would you like to keep it very at a lower point? No idea. So the center of gravity in the empty thing is here. The center of gravity for the filled up is also here. Okay, even though this is filled up, the mass is everywhere here. So center of gravity is going to be somewhere at the center. Whereas here, this is an empty bottle, whereas water is heavier. So the center of gravity will be somewhere here. Okay. So what do you mean by stable? When you tilt this, right? When I tilt this, okay, I have space here. When I tilt this, the gravity, if the center of gravity is a topmost point, higher, it will very easily fall outside this. The center of gravity is very the very lower point, then it will be falling inside the base. So this is the concept of stability. So that means we like to keep the center of gravity as close as possible to the ground. If you see some of the cars, right? If you see from the back, you will see the shape will be, instead of the car being like this, if you see some cars, it will be designed something like this. Even I think Swift is like this, right? It will be having a little bit of bulge this way. I'm talking about, if you see from the back.
Yes, sir. The new ones have a wider back.
Yeah. So why do you think they do that? Basically, they are trying to increase the area. So if you
Yeah, so
increase,
the balance will be equal.
yeah. So if you increase this base, right, then you will have more space for the center of gravity to fall inside. So that means it's,
Sir, so that if even if the car tries to go for rolling over, it won't happen.
yeah. So we are talking about stability here. So this is more stable than this one. Okay, this is a very interesting topic. Okay, I'm sure you must have seen this. What do you call that? I forgot the name of this. Must have heard about this Tanjore dolls, right? So no matter what you do, right, it will come back to its original position. Why? If you really analyze that, they would have made the base very, very heavy. So next time when you see a Tanjore doll, right, buy it and try to analyze it. You will see that the top part will be very light, but the bottom part will be very, very heavy. So when this part is very heavy, the center of gravity will be here. So no matter how you tilt, the center of gravity will always fall. So no matter how you tilt it, it will fall inside the base. So which means it will come back to its original position. Okay, that's too much. Maybe we don't need all these topics. Since some of you are kind of interested, I thought of sharing these things. Okay, so that's what we are talking about here. So even in boats, right? This is a very important thing. So very often we see some, the newspaper, we see that, in the Hogan, right? There was some accidents. I don't know if you see it in the paper. So they take a boat like this, and people are supposed to be sitting like this. And then what do you folks do? Many people, what do they do? Without thinking, right? To take selfie, what do? This guy will come here, this guy will come here, and this guy will come here. And how stupid it is, right? Imagine that you have the boat, something like this, and then all the 4 people are standing like this. Right? So obviously it's going to tilt like this and then cause an accident. And this kind of accidents we keep on hearing every now and then. So as you study physics, think about all these things, and just for taking a selfie, don't do stupid things. Okay. So whenever you are taking a selfie, make sure that you are in a safe place and it's safe to take a selfie. So don't do such stupid things. Okay. Instead of studying physics, you should not make these kind of errors in your life. Okay. And this is like a very heavy, very expensive mistake. Okay, it will be costing. You'll be losing your life. Okay, where did we? I think we spent too much time on the outside stuff, but all these things is also important for, again, as I always say, it's not about, studying something and getting marks. You should know how to apply it in your real life. Okay, coming back to this is a very interesting thing. Look at this. When theta is equal to 0, what does that mean? There is no banking at all, which means it's a flat road. So let's try what will happen if I put theta is equal to 0 here. Tan 0 is 0, tan 0 is 0. So this term and this term will go away. Take it down as a special case. So v squared max is equal to, this term goes away, tan 0 becomes 0, this is 0. So what is left is gr mu s divided by 1 minus 0, which means 1, which is nothing but what you got in the previous derivation. So if you go back and check your pattern, v squared max is equal to mu rg. Here also you get the same thing. Anybody still copying the derivation? If you're copying, let me know. I can wait for some more time. Copied, special case. So Elvin, you are saying, sir, people nowadays will go to any extent to get likes and followers. Okay. Yeah. So that's what I'm saying, do whatever you want to do, but don't do stupid things. Okay. Physics is there everywhere in day-to-day life. Okay. You should understand some of the mistakes, it's nothing wrong. If you make some mistake, you can learn it and correct it. But these kind of mistakes, it will cost you your life. So you have to be much more careful. And many times, you folks, the mistake I have seen is when you are in a group, right? It's a mob mentality. So when you are in a group, when you have some 4 or 5, friends together, you forget, what you are doing.
So firstly, they won't care about that. So they just go for an angle and then they just start clicking.
You go for a?
They'll just tilt their phone like an angle, weird.
Okay.
Yeah.
Yeah, particularly in roads, in tourist spots, you have to be much more careful. Okay. Likes and followers, you can get, always, as you, if it's good, you can always get it, but you have to be, much more careful. Okay. In fact, I don't know if you folks know this or not. Some countries, European countries and, America, US, what they do is, if you are a mechanical engineer or an automobile engineer, they give some kind of extra marks when you take driving tests, because they think that you know much better than others. So when you take the return test, they'll be giving you some extra points. I don't think that is the case in India, but many countries like Europe and US, they give this extra points for driving tests. Because a lot of things which you study here, right, you can be applying it in the real life. Okay, let's see. I think this topic is coming in the next chapter, chapter 6. This one, I'm not sure if I talked about this in the previous chapter. Anybody remember? Roundabout, right? I told you that, you will feel like you are getting raised up, so that, you will not feel the floor at all. Anybody remember that? Did we talk about this or not? The circular motion concepts. No? Okay, let's quickly talk about that. Again, the handbook will give you the concepts. Okay, you need to know how to apply it in the real problems. So that's the idea behind giving this handbook. Forgot to make it a blackboard today. Have you been in this kind of ride where people will be, I forgot the name of this ride.
So not the ride, you can see the hotel doors.
What's that?
The five-star hotel doors. You'll have to take a circle. You have to go through the door which keeps rotating.
Oh, that is a rotating door. That's a different thing.
Okay.
This is,
This is a separate ride, sir. I've been in it.
what do you call that ride? Anybody know this name of this ride?
Sir, I don't know the name, sir. It was like, I don't know the name actually. It was celebrated, some day was celebrated. That time in the carnival, this ride was there.
Okay. So if you go to this MGM Disney World or Disney World, those kind of places, there'll be a big cylinder like this, and you will be entering into the door, and then people, many people will go and stand inside this without
Is it a
knowing.
trampoline?
What's that?
Is it a trampoline?
Trampoline is something like like an elastic band, so people jump on it, right? I think that's what is trampoline. Is that right? That is different. So I'm talking about like a cylindrical container like this. So this entire cylinder will be spinning at a very high speed. So as you go inside, what will happen is, because of the centrifugal force, you will be sticking to the surface. I mean this. So because of that, what will happen is, again, it's hard for me to explain without showing you the. See.
Sir, it's merry-go-round, sir.
Merry-go-round.
Yes, sir. Yes, sir. Yes, sir. So it's basically where you have to stand in the place and then somebody pushes. Yeah.
No, I'm not talking about this one. I'm not talking about this one. I'm talking about, I forgot the name of that.
So if you're talking
I
about
think it,
circles, I'm not sure about theme park, but those gravitational not catapult, something else.
sir, I think it's like some spaceship ride or something.
No.
Sir, it's basically where
The fourth
the
one,
G
sir.
force,
First
G
row.
force.
Yes, sir.
Yeah. So you see in this picture, right? You can see the floor is somewhere here. So people are standing there without the floor at all. Okay. Of course, it's not a standstill picture. It's actually, it's spinning at a very high speed. It's just a picture is, standstill. So in one particular situation, it looks like, they are sticking to the, so you can see the floor itself is not there. Same thing in this picture. So people get pushed, and then you see in this particular place, right? Without, touching the floor, you'll still be, hanging around there.
Yes, sir.
Is there any specific name for this kind of ride? Gravitation,
It's a starship ride. Yes, sir.
starship. Okay. This is very interesting. Look at this girl. She's crying. This girl here is, laughing. This
So
girl
people
here.
have passed out in this.
Yeah. Because you get a feel that,
I've
you are kind
experienced
of,
it. I've
you
passed
get a
out
feel
twice.
that you are hanging in the air, right? So you don't feel the floor at all. Okay, so I think if you had been to this ride, probably you'll understand this better. So let's come back to the theory. So what's happening here is our entire body is going around a circle. Whenever there is a circle, there is circular motion, there is a centripetal force. Okay. So what happens is to go around a circle at a particular speed, right? There is a normal reaction. So how to say this? I told you there is always something called pseudo force. So I told you when the car is taking a turn towards your left, you will get pushed towards the right. We have talked about this many times. Okay. Why? Because did somebody push you towards the right? No, nobody pushed you. But because of the turn which the car is taking, you feel like you are getting pushed towards the right. Similarly, when the circular motion is happening, right, you will get pushed towards the wall. Okay, or that's a pseudo force. If you understand this, which we very often every day we experience this, you will be able to understand this. This is for circular motion. Sir, I don't understand this means. You can imagine when the bus is suddenly started, you get pushed backwards. When the bus or car is suddenly stopped, you get pushed forward, right? You go and hit the forward seat, and that is your pseudo force. So really there is no force, but you feel like you are getting pushed this way. So since you are hitting the wall, right, there is a normal reaction force. So when the speed keeps on increasing, what will happen is at some point you will not feel the floor at all. You may be wondering, sir, how come my weight should be acting downwards, mg? Well, weight should be acting downwards, but then there must be some other force which is acting opposite to it, equal and opposite, and that will be your F friction between your body and your body or the clothes which you're wearing, and then the surface of the cylinder. So that will be mu into n. Who is acting towards the center? Normal reaction, right? What do you mean by normal reaction? Normal to the surface. So that means this is your normal reaction, and the friction is what is holding you upwards. So as the speed keeps on increasing, so listen carefully. So N is equal to mv squared by r. And this should be equal to make you float upwards. I mean, not floating, but you're not falling downwards. Come out of the floor. Don't forget that here in this case, when this and this are equal, right? You will not be feeling the floor at all. But what if this is higher? Then this force is higher and this force is lower. And that is exactly what is happening in this kind of situations. So you see the floor is far below the people over here. So the floor is here, but then these people are, hanging around a higher height. But you see, some heavy persons, you can see they are almost close to the floor. So this lady looks like she's a little bit heavier. So you can see that she's a little bit lower here. So that means the mg here is higher. So what this means to say here is, as the velocity increases, right? You know that v is equal to r omega. We studied this in the previous chapter. So m r omega square. Okay. So mass of the person is fixed, radius of the cylinder is fixed. Omega, as the spin increases, omega as the speed increases, omega increases. So as I increase this omega, listen carefully, very, very interesting concept. As omega increases, normal reaction will also increase. If the car is turning very quickly, you will get pushed more towards right. So as the as omega increases, n will also increase. As n increases, what happens? Yeah, friction will also increase. So as F friction increases beyond mg, what will happen? You will start going upwards because F friction is upwards. So as F friction is more than weight mg, the person will move upwards. Without the floor in the bottom. Without the feet touching the floor. So take it down, very interesting concept. Okay. So as the speed increases, you will be going up. In fact, if the speed is high enough, maybe you can go and touch the ceiling. Very interesting concept. So take it down properly. Maybe I have not given all these details in the handbook. Maybe I should improve these things. So take it down properly. I think there is some numerical questions based on this. So if you understand the roundabout ride, you'll understand this. Okay, so I'm going to stop here. Any questions? So start doing the remaining examples. Okay, almost done. Maybe another 5% topic is remaining. So we'll get started with the numerical in the next class. So maybe I can give you a theory test. I will fix it. Okay. So theory test we will have it on Wednesday. So maybe we can have one more class. So theory test will be on Wednesday. Okay. So start preparing. So you have a lot of theory questions in this chapter. and of course numerical also. Or we'll do one thing, we'll finish it and we'll have it together. Okay, so if you have doubts, stay back, otherwise you can leave. Thank you all. Bye.
Thank you, sir.
Thank you, sir. Take care, sir.
Thank you, sir.